Guys, alright, so this is our final video for today, and it will be going over an introduction to R and RStudio. So I'm not the best coder at R, but I'll do my best to explain some of the basics. So first off, here is just R. It's like R console. It's garbage and I hate it. So what we're doing is we're doing RStudio, which essentially has a graphics user interface. I think I said that right, or a GUI. So it kind of it's not so simple. It adds a whole bunch of like other features and things like that. It's just easier to use. This is what we're using. So directions on how to do all that are going to be in the plus and intro to R thing on the second page. See, so here we're talking about some things. I did a video on that. And then down here it's like download and install all in RStudio before viewing the video, and I completely agree. You can't follow along with this if you don't have both those things. So here's all of your resources to be able to do that, and then here is a nice cheat sheet that kind of like shows some stuff. Do these things, and we'll go ahead and get started. So, welcome to RStudio. To begin with, annotate your code. I don't care if you don't want to. You're gonna want it. You're gonna want to annotate your code, which means you're gonna put little comments in there so you can refer back to it later. I have referred back to code from years ago, and I would have had utterly no idea what was going on if I did not annotate it, which would have meant days of research and going back over things. If you just write code, you're going to come back to it probably in a week and not know what's going on. So annotate, annotate, annotate. You never know who you might need to share it with. By annotation, the way you do that is you write a number a number sign. So you just do that, and then blah, 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 blah. And you see how it's all green? That means R is like, I don't care about that, which means that it won't run it. So annotate your code, guys, for reals. If you need to load in like a package or something, a package is sort of like a collection of like functions and things, which, sorry, my garage door is going up, which allows you to perform more specialized functions and stuff like that. You would just type in library and then in parentheses the name of that package. So base is just your basic one. It's already loaded, but I'm just showing you. So you do that, and then here's how you run it. You can also highlight a whole bunch of things to run something. And when you run something, or I can just do that. If you run something, it pops up down here in the console. So since it's blue, it's not showing any errors. That means it has successfully downloaded the library or whatever. It's downloaded base, so not to worry. Down here is going to show what the output of you running something down here in the console. You can also just type stuff down here. So and then I'll press enter and see it runs it there too. So you can type down here, or you can type up here. I like typing up here and then just running it down there because this becomes a garbled mess after not too long, and you don't want to like lose any of this up here. So this is just more organized. If you need to, you can go back to like history over here and see what all you've plugged in and run. I don't know what connections is. And then environment, you can like import data sets, which we're not doing today, but you will definitely need to in the future, like save, stuff like that. Yeah, so you can go over here to files, and you can create new folders and things like that. See, this right here shows how you can get to specifically where we are, which is I created a new project. I called it 120 Lab. A project or a directory essentially is kind of like a direct line to where that like data set is. I picture it kind of like a mega folder containing a bunch of little folders. I know I'm not great at explaining it, but it's kind of a weird thing to explain anyways. Alright, so we've got, you know, I did a new file and etc. That's all the basics here, so let's get back into it. Alright, so creating a new object while assigning a variable. So that could be something like x equals 10, or so you can use the equal sign, or you can use the arrow and then the dash. Either way, this is like the more traditional way, but you can use equal. I prefer equal myself. So when we do this, run. So you see down here, it ran. There were no errors, and then it'll go to environment, and it'll show your values. So currently in this like file, this is what I have assigned so far. And then now I'll run y, and now look, see, y is equal to 20. So there's your variables. You do everything with objects and variables, so just a heads up. So okay, and now you can try and make sure that it's working right. So I'm going to just run just the letter x. And so see, it comes back with 10. I've got all the things that it'll pop. I've got all the outputs saved up here with annotations, just in case something runs wonky on my computer, because you can never trust a computer. So let's try running y. Alright, so y returns like 20, just like we assigned over here. And then let's run z. Plot twist, we didn't assign z to anything. So it'll say error, object z not found. Well, yeah, because you didn't assign anything to z. So okay, let's do that. Run z. Now we can see over here, z is now 30. Alright, let's try running z. Plot twist again! Oh god, oh, I messed that up. Hold on. Oh no. Okay, so we did a capital Z instead of a lowercase z. R is case sensitive. So if you want to really run that, you would have to run z. That's lowercase. And so it'll pop back up with 30. So that's right. Down here, you'll see that you can just reassign variables at will. So let's say I decided that 30 is not a cool enough number, so I'm going to assign z as 40. Let's run it. Alright, so we see over here it's changed. And go over here, run z, and yeah, see, it pops back up with 40. So that's kind of the basics of that. You can name objects, so like we were just using x, y, z, but if you're running like a billion different variables and stuff, you're going to want to have more specific names. And trust me, it gets complicated really fast. So here are some examples of it. We're going to go with like limb length is the mean hind limb length of salamanders in the study area. It's just an example. So we could name it limb length here, limb.length, this monstrosity if you hate yourself, and so we'll run all three of these. You'll see over here all three of them have been assigned the same number. It doesn't really matter what you want to name it in that case, name it whatever, but there's a couple rules. So let's make sure they all ran right. Okay, so this pop back with 23.1. Run this pop back, yep. This monstrosity, yep, all worked. So here are some examples of invalid object names. So names have to start with a letter, and they can't contain spaces. Spaces are forbidden in R because the computer's like, what? No, just don't overcomplicate things. Don't add in spaces where unnecessary. So, if we try to run this, it'll be like unexpected symbol, and the symbol is the space. If we go down here, you can't have an exclamation mark. Those are not allowed. No excitement allowed here. And then this one starts with a number, which is also not allowed for whatever reason. So don't do that. yeah, so just name your objects correctly. Now we'll get into some of the basics of R. It can function like a basic calculator. So let's try this. It understands, what was it? Please excuse my dear Aunt Sally with like parentheses. You can look up all the basic symbols for it, like, what was it? This is divide, this is multiplied by, and then there's, of course, plus or minus, I believe, and then, hold on, where is it? This will refer to, like, to the power of. So that's some of the basics of that. Alright, so we did this, but this is the long way of doing it, right? So let's use sum for summary. Let's try and run that. It got the same answer. Look, it simplified our life a little bit. And then we'll just try using straight up mean. But it returned 2. That's not right. What a plot twist. R is difficult, and it will only, like, mean has to be trimmed, essentially. So here's how you figure out more about why functions didn't work. You'll do question, and then whatever it is, and then you'll see over here in the help, it'll pull it up. And if you read through this, it'll say it has to be, like, trimmed. So you basically can only run mean on, like, one object, which means that you're going to have to concatenate things, because this is 4 different objects separated by commas. So what we're going to do is we're going to assign this variable e, and then we're going to run the function c, and then in parentheses, c is for combine or concatenate, and it'll, like, kind of keep the values separate with the commas. It knows what's going on there, but because all 4 of those values are of the same type of element, it can basically combine them into one object, if that makes sense. It's hard to explain. I'm not very good at that. But it turns it into a vector. And so let's run it. Alright, so over here, we'll see. Cool. And it's got, like, numbers 1 through 4, so it shows, like, 4 values. Now let's see. Did it work? Yes, we already know, but just saying. And then let's do the mean of E. Wow! It returns back 5, which means it worked. RStudio's got to be difficult, but that's just, it is what it is. And I am not a coder, so I don't understand the brains of coders. I'm dating one, but God bless, they're very strange. So anyways, this is how all that works. Life is better with vectors. We just created one. The C function creates a vector. It's a sequence of data elements of the same type, so they're all numbers, essentially. They're all, like, integers or whatever, or numeric. You can check the length of it. So basically, like, how many bits and pieces of E are there, and so there's 4 different values separated by commas, so it returns back 4. So you can check that. Alright, so let's discuss 3 basic types of data in R. There's numeric, which is essentially a number with a decimal or a fraction. There's an integer, which is a number that is whole. And then there are characters, so that's like any combo, letters, numbers, words, it doesn't matter, that is contained in quotes. So, okay, let's start with this. Alright, so we got 4.7 is A. And now we're going to check the type of element that A is by using the class function. So, like, what class of whatever is it? And it returns back numeric. And we can check the class of E, which is the vector we just created above, remember, to run the mean. And it'll say numeric as well. And they are. Remember, because they were all, like, numbers. And then here is 6, which is a whole number. You would think it returns back an integer, but automatically R treats numbers as numeric for, whatever. So what we're going to do, if you want to turn it into an integer, you're going to use the as.integer, and then with the parentheses, you'll put in whatever function to change it. So b is equal to 6. I ran that, yeah, right here. So, and like I said, it'll return back that it's numeric originally, so we're going to change it. So we are naming the variable b.int, so like b is an integer, and then we're using the as.integer function to run it. So here we go, run. And now we're going to check and see what it says. Yeah, it ran, so 6. So what's the class of b.int? It's an integer now. It's kind of like exporting documents and stuff in a way. And it's what it reminds me of, you know, changing it from like .mov to dot something else I forgot. Sorry. And then here's, last but not least, we got character. So I don't know why we've chosen this, but this is what we've chosen. So we got very big bird. D is equal to 2 very big birds. You can run both of these. You can see it over here. See? And then now we're going to check the class of C, and that's going to be character. And then class of D is character. So you can see they're in quotes. It doesn't matter if there's letters, numbers, or whole words. Since they're in quotes, it's going to be treated as a character. Okay, let's get into it. Now it's time for bar plots, which is kind of the main thing that you're doing this for, because you have homework, right? And this is why you're watching this video, to learn how to do your homework, so you don't have to listen to me anymore. So, here we go. So, first, what you might want to do is check out, what up with these bar plots? What's going on? And it'll tell you a ridiculous amount of information, and you'll just kind of go through and be like, oh, okay, whatever. And see, it says that you need a height. So, you need a height object representing data points. And also, don't forget, you need to calculate your means beforehand, because that's kind of like a separate thing. So remember that we're making bar plots based on teeth proportions from that lab activity, analysis of dentition, and we're going to be using pictures of mammal skulls in the files. So analysis of dentition. Here, if you go to the files, you'll see mammal skull images, and it's going to have all these guys. This is all relevant. And then it'll be somewhere around here. Analysis of dentition. So here we go with the counting teeth and all that. That's what this is all going to be for. Anyways, all right, so let's get back to it. Here are some made-up proportions, and keep in mind that proportions have to be between 0 and 1. It doesn't make any sense if it's above or below. So here's some made-up ones. We're going to call it canine.proportion, because these are the proportions of specifically the canine teeth in 4 mammals of each type of eater. So we'll be doing carnivore, herbivore, omnivore. So this 0.01 is the mean of 4 herbivore mammal skulls proportions of canine teeth. 0.11 is for the carnivores, and then 0.09 is for the omnivores. So we're going to make a bar plot. Oh, but first I got to run this. Don't forget to run specific parts of it. We'll go over here eventually. So that ran. See, no errors. And now we're going to run bar plot. And down here it'll show in the plots tab our garbage plot that we just made. It looks like, but there's no anything that we need. There's no title or labels or anything. So let's sexy up this graph. So here's a trick. We're going to be using multiple lines. It's like these We'll be using multiple lines to run this because when you combine it into one, it looks like a massive burning pile of garbage, and it's way harder to troubleshoot and see where you made an error when things aren't nicely separated and organized. So we're going to run this with multiple lines, and the way you do that is you see here how I didn't close the parentheses. Well, you'll look down here, and right before I put this annotation here, I closed the parentheses down here. So that's really important. A lot of times I'll accidentally, I'll have errors for hours. I'll be so frustrated. It's because I forgot to open and close parentheses somewhere. So that's how you put it into multiple lines. You put the parentheses at the end. So let's run this. I'll run through what every part does. Now we're talking. That's better. There. Gonna make it a little bit easier to read. Okay, so what we did was we started with the function bar plot, and then we're using k9.proportion because that's the variable we defined earlier. It's got the numbers that we need. So the main right here, main refers to the title. So you put all this in quotes. Main is equal to, because it's a character, in quotes, and then you put your title. And we picked a relationship between diet type and canine teeth. XLab refers to the x-axis label. So you'll do XLab is equal to, and then in quotes, this, diet type. So you can see down here on the x-axis, there's our beautiful label. And don't forget, you got to put a comma after each part of this, because that's continuing on that this is all going to be run in as one, and it separates everything. Y lab is a y-axis label, so it's the same thing but over here, so it's a proportion of canine teeth, and don't forget the quotes. And then y lim is like y limit, or how high you want your y-axis to go. So we set it goes from 0 to 0.12, and you can see that it followed through on that over here. And then names.argument, that's like the argument for assigning names to each part of your vector here. So I did herbivore, carnivore, omnivore. Please keep in mind that you need to put those labels in the exact same order as the numbers that you put in here. Okay, so like this 0.01 is for herbivores. That's why I put herbivore first. The second one is for carnivores. The third one is for omnivores. If you get those mixed up, then your graph is completely wrong and it doesn't make any sense, right? So you got to make extra sure that you do that. Again, don't forget about calculating your mean. Calculate your mean before you try and run the bar plot. It should be really easy. You basically just copy and paste and put in your own numbers. So here's an example of calculating the mean. Let's just say that these 4 numbers are of the 4 mammals we chose to do for herbivores. So I just picked O is equal to, and then don't forget you're going to use the concatenate function, or the C, and then in parentheses, and make sure you put a comma by each separate element or whatever. And then it'll run the mean and it'll be right. And then you can just take those and plug it in up here basically, and there you go. It's basically all done. You just got to kind of plug it all in. But the main thing that you're going to be doing aside from this is you're going to be calculating these proportions, and even that is going to be really easy because it's going to be basically plugging in. If you go to the lab activity or whatever, it'll tell you how to do it. You're going to count all the teeth on just like one side of the skull, right? Because they're symmetrical, so you can just count on one side and then multiply by 2. And then it has a link to the student data sheet. You're going to need to download that before you start this data sheet. over here, it's already got the functions plugged in. You don't have to mess with that just yet. All you have to do is plug in. And I've just like made these up or whatever for one specific mammal. I picked an omnivore. So I counted that they had one canine on the upper right, one canine on the lower right jaw, 3 incisors on the top right, 3 incisors on the lower, 4 premolars and molars on the upper part of the jaw, 5 on the bottom, and then total teeth upper and then total teeth lower. And just by doing that, it output proportion of canines, proportion of incisors, and proportion of premolars and molars already. So that's basically all you need. So you can go ahead and get it for 3 others and then calculate your mean and plug it into your bar plots once you have all your numbers, and you're good to go. This is basically you're just going to be plugging stuff in. So just don't mess these up and you'll be good to go. Re-download it if you need to. So I hope all that makes sense. Alright. That's kind of the basics of that. Hopefully everything I said makes sense. We'll get into fancier graphs later. Bonus points if you can change the colors of herbivore versus carnivore versus omnivore. I know how, but we'll learn that later. But if you can do it now, bonus points. And that's basically that. So hopefully that was kind of helpful. Good luck. And make sure you're reading through the appendix at the same time.